All. In today's session, let me learn about how to analyze your given asynchronous sequential circuit. So there are three parameters to analyze your asynchronous sequential circuit. So you can analyze your circuit using your logical diagram of that asynchronous circuit, or else you can use the state tables and we can analyze that and we can achieve the stable considerations on your asynchronous sequential circuit. So there are three parameters to do that analysis using your transition table, flow table along with stability consideration. So let me go one by one. So transition table. So how to write that a transition table is, so these transition tables are used to analyze your asynchronous sequential circuit, and these are these tables are derived from its logical diagram of your asynchronous sequential circuits. So procedure to obtain your transition table is determine your all the feedbacks in your given circuit, as well as you have to map your present states of your input and your next state of your input, with the small y is your present state and capital Y is your next state, so which shows your each feedback loops, as well as we have to derive here the next state outputs. So next, plot each y function in using your k-map techniques and combine your all the maps into one table. So you don't have only one output or one state at your sequential circuit design, so you have multiple next states we have. So hence we have to draw for each next state one individual k map. Now you have to draw the transition table. Upon drawing that transition table, we have to circle the stable states. So where the stable states are denoted like so initial state, if it is 0 0, if your next state upon giving one input with x equal to 1, if it comes into your same state, so then it is known as your stable state. So we have to circle those stable state in those rows of your transition table. So this is the method. So we have to derive your transition table from a logical diagram. So this is a one example we have taken with the two states y1 y2 and what with one single input. So external input is present input is x, and we have obtained your two next states which are capital, we denoted with the capital Y1 capital Y2, and these are derived from its present input with your present states. So these feedback elements, so where we are connected your next state as your present state, so hence that is symbolized with a small letter y1. So now when you indicate with the, for example, now so in your sequential circuit design, so we represented your present state as your qn and your next state as your qn plus 1. Here instead of that qn and qn plus 1, so we are going to represent your next state with the capital letter y1 and your present state with a small y1. So hence the feedback the output which are fed back to the input again, so which are treated as your present state. So we have two present states here along with your two next states with a single input. Now so let me learn about so how to derive its output function. So by just observing your the logical diagram, so we need to obtain your the equations of your or the how it is dependent on your present input and present state, that can be derived from its expression by just observing your logical diagram. Now here we have y1 x and y2. So now in order to obtain your y1, so it's the OR term of two product terms which comes from your x into y1. So this is the first AND gate, so which will give you the first product term as x into y1, another product term which comes as your x bar into small y2. So present state which I have treated as your 6 bar into y2. So hence y1 is equal to summation of your x y1 plus x bar into y2, whereas y2 is the next state. So this is your second next state, which is your y2 of this circuit is equal to the addition of your two product terms which are x bar into y2 along with here we have your x into y1 bar. So hence here y2 is equal to x into y1 bar plus x bar into y2. Now by replacing the possible present states y1, y2, the combination of two present states we have. If you have two present states, the possible assumptions on your present states are 4. So 0 0 0 1 1 1 as well as your 1 0. So now, so for each possible present state assumption with the x value of 0 and x value of 1, we need to find the capital y1 or the next states of your given circuit y1 and y2. So now we found first, we substitute here x value equal to 0. So when x value is 0, so y1 is assumed as here. 0 is my y1, x value is 0, x bar become 0 bar become 1. So next y2 is 0. So hence capital Y1 here it is equal to 0 plus 1 and of 0 is 0. It is equal to 0. The same manner. So find it for y2. So by replacing here x which is 0 0 0 value and y1 y2 is 0 0, we obtain here y1. So now the same manner find it for y2 by replacing y1 y2 with a 0 0, x value with a 0. So y2 is obtained as x is 0, y1 bar is equal to 1 plus x bar is 1, y2 is 0, hence y2 value. The next state on your inputs of your present, your input x equal to 0, small y1, y2 is present states are zeros. So you obtain both are 0 0. Hence the first square we substituted here 0. Next in the same manner you have to find for x value of your 1. So for an x value of 1, the next states of y1, y2. So now let me find for x value of 1 with the present state of y1, y2 0. So now if y1, y2 are 0 and x value is equal to 1, let me find here the next state y1 value is equal to x is 1, y1 value is 0, x bar is 0, y2 value is 0. So here also we obtain 0. Next capital Y2 is equal to x is 1, so y1 bar is 1 plus x bar is 1 bar is 0, y2 value is 0. Hence here 1 and of 1 is equal to 1, 1 or of 0 is equal to 1. So hence here y1 value for the present state of 0 0, x value is 1 is 0, and for an y1 y2 0 0, x value is 1. So x value 1, so y2 value is equal to 1. Now upon finding all these combinations, so for each present state of your 0 0, so for each input substituted on your one of the input x value and x value with 0, x value with 1, we found the values of your next state y1, y2. Now upon writing all these values, so we obtained a table, so which is called, these are your individual tables of your next states y1, y2. Now if I interpret these two values into a single map, so then here with y1 y2, so capital y1 is 0, capital y2 is 0. So with the x input 0, so hence here we obtain a state, next state, if my present state is 0 0, next state on your y1 is 0, next state on your y2 is 0. Next, so x equal to 1, capital y1 value is 0, capital y2 value is 1. Hence for an input x equal to 1, if my present state is 1, y1, y2 is 0 0, next state or a capital y1, capital y2 is 0 1. Next in the same manner by just interpreting all these squares, so 1 1, here 0 1, then 1 1, then 1 1, so with the present state of 1 1 and x value 0, so we obtained a state transition from on your input with x equal to 0 is 1 1. Next with x input 1, so with the present state of 1 1, it will be 1 0 on your next state. Along with this, so here my present state is 1 0, x value is 0, so y1 value is 0, y2 value is 0 0. Next here x value equal to 1 with the present state of 1, so y1 value is, capital y1 is next state is 1 along with 1 0. Now we obtained your state table, here transition table. So now this transition table will give you the transition from one state to your other state. So how these states are moving from initial state to the next state with the possible inputs of x value equal to 0, x value equal to 1. So now with x value equal to 0, so here present state is 0, next state is also equal to the same state which is your present state. Hence, so this becomes the stable state. So because with the one input of x equal to 0, it attains the same state which is on your present state, hence it is stable state. So which is on the same state, hence we would define that as state as a stable state. When present state is 0 0 with x input 1, it is moving to the another state which is called as a transition state, or the next state is 0 1. So next, if 0 1 is my present state, x input is 0, 1 1 is my transition from present state of 0 1 to next state with its x input 0 is 1. In the same manner, so 0 1 is my present state with x input 1, so it is moving to the other state which is called as 0 1, but it will be itself for the input of x equal to 1, so it will be around in itself, it is in the same state, so with x equal to 1, so hence it becomes the stable state. So 1 1 with x input, next state is 1 1, so here present state is 1 1, so with x input 1, so it will be in the same state, the next state is also equal to the present state, hence it will become the stable. Next 1 1 with the x input 1, so it is moving to the other state which is 1 0. Next here we obtained your stable states, so if it is with one input of specific input of your input, if your next state is as like your previous state, so then that will be known as your stable states. So like this we have your 4 stable state in our given example. So hence here that 4 states, so initially it is 0 0 0 1, then it will move to your 1 1, thereafter 1 0, again it comes back to its initial state. So like this, so we have to find here the stable states as well as here unstable state. So for 0 0, so it will move to the other state which is called as the transition state. So like this, so when you wanted to find your the stable state, we can also include your input with the x input, so with your present state. So now the stable state, if I include with the present input, so 0 0 0 is here one of the stable state, next 0 1 1 is here another stable state, 1 1 0 is here the third stable state, 1 0 1 is your fourth stable. So this circuit would have your 4 stable states, and it is having 4 unstable states. Those are your 0 1 1. So first let me start with this. So 0 0 0 0 1 1 and 1 1 0. So here, so we obtained 0 0 1 0 1 0 and triple 1. So out of the 8 states we obtained 0 0 3 6 along with 5. So now the unstable state, so if I include your present input, so then it would become 0 0 1. So the missing numbers which are there in your stable state will be your unstable state. So 0 0 1 0 1 0 triple 1 as well as here 1 0 0 are denoted as your unstable state. Next, a flow table is defined. So like in your previous state, so in your previous transition table, we represented the states with your binary values. Now instead of your binary values, let me replace so that with your alphabets. So if I replace that with the alphabets, so then so this will become the flow table. So in that flow table, so we can also include your outputs too. So now in the last example we have not indicated any outputs, but this is one example. So with the next state, present state and next state transition inside this square along with outputs if you represent, that become your flow table of your asynchronous sequential circuit. For example, now I have taken one example to explain this flow table. So here I have mentioned here a logical diagram. So in the previous case I have taken one single input with the 2 present state and your next states are treated as your output. So now in an analysis of your sequential circuits, we can take out the output from your combination circuits too. So hence we are taken here Z is the output, so Y is your next state, small y is your present state with the multiple inputs. Now if my multiple inputs, so now y is equal to, in this equation, so y is equal to, here I have mentioned here, y is equal to x1 into x2 bar. So as here y is some term, so which is equal to, so x1 into of x2 bar, and here x2 into x1 into y1, x1 into y. So hence here, so it is a summation of x1 into x2 bar plus x1 into y. Whereas z is the output, so which is an AND term. So it will be AND of your variables x1 into x2 into your present state y. So into your as well as your present state, the feedback which comes from your circuit, which will be your small y, is considered to obtain your z output. So z is an AND term which is x1 into x2 into y. So now with possible x1 value, x2 value, we will find your next state along with the output. So next state is y is equal to x1 into x2 bar into x1 y. So let me take for first one example, x1 x2 are 0 0, y is equal to, and y small y is equal to 0. Now if I replace that, so x1 x2 as 0, so 0 into 0 bar is 1 plus x1 value is 0, y value is 0, hence the output value next state is 0. In the same manner, for the same inputs of your x1 x2 y1 y value, let me find your z. So z is equal to, these two inputs are 0 0, so product of these three, right? So hence these three products will give you the 0 output. So like this, so if I write it, all the values are substituted here, present state and your next state, we can obtain your next state, present state of your circuit along with the inputs, we can obtain your next states. So 0 0, you obtained a 0 output as your next state, x1 0 1 with the present state 0, x1 x2 are 1 1, you are obtaining here with the present state of 0, next state is also equal to 0, 1 0, you obtain your 1. So in the same manner, so present state of 1, so 0 0 input, output is 0, so 1 out 1 present state, 0 1 is your input, so next state is 0. So upon writing these all, so since, so your present state is 0, for an input of 0 0, it attains in the same state, so it is stable. So 0 1 also, it attains the same state, which is the initial state, so 0, we encircle this, so 1 1 also 0. Next, whereas here for a 1 present state, you obtain your 0 state, and for 0 1 you obtain your 0 is your next state, but whereas 1 1 input, for a present state of 1, it will be in the same state, hence we encircle the stable state here. In the same manner, we will find for z, so z output is y into x1 into x2, so AND gate will give you the logical 1 output if all inputs are 1, so only for that combination it will be 1, and the remaining all are zeros, so hence we wrote these all as your outputs. So like this, so your analysis is done using your flow table or your transition table. Now, so race around condition. What does mean by race around condition? So this race around current condition is explained. So on a single time, if I am going to modify your input combination from 0 0 to 1 1, so first I have to move to your 0 1 state, thereafter I have to change your, so at a time I can't change your both inputs to logical 1 state, so hence, so 0 0 will first move into the state, that input change will have only one bit variable change, which is 0 1, and then it will move to your 1 1, so or 1 0, or from 1 0 you can have your 1 1, so but your asynchronous sequential circuit are sensitive to it, or it is responded to the changes in your inputs immediately. So since that, so output would have your false output for a duration of time. So in order to avoid this logical race, so we were going to use the gray code technique. So the binary sequence must not be followed here. Instead of that, so we have to follow the binary input sequence. Only at a time, only one input must be changed. So here 0 0, next 0 1. After this, if I wanted to change, I should not go to your 1 0. Instead of that, I have to move to the changes in your input to 1 1. Then we will apply to the 1 0 state. So like this, so we can avoid your race, race condition in your outputs of your asynchronous sequential circuit.